Hi everybody and welcome back to the part 2 of the bidirectional replication. In this lecture I'm going to talk about one subject: how to configure conflicts detection and resolution in a bidirectional configuration. This is just a reminder of the bidirectional configuration challenges that I have talked about in the previous lecture. We have covered the first 5 points, and I'm going to cover the last point in this lecture, which is how to handle conflicts in Oracle Golden Gate bidirectional configuration. Following are the possible conflicts that could take place in a bidirectional configuration. One possible conflict is that the replicate may insert a record that is already existing in the target database. Another possibility is that it may try updating a record that doesn't exist in the target database. Or the record exists, but it's different from the record that was in the source database before updating the record. The third possibility is that the replicate may try deleting a record from the target database, but the record doesn't exist in the database. Or the record exists, but it was different from the one that used to be there in the source database. With Oracle Golden Gate, you can define routines that tell the Golden Gate how to respond to each of those conflicts. This is what you are going to learn in this lecture. Because of the asynchronous nature of the Oracle Golden Gate synchronization mechanism, having data conflicts is inevitable in bidirectional configuration. To minimize data conflicts, you can try to have a low network latency or apply a data policy in your system that will lead to minimizing data conflicts. For example, you can have one database which allows DML operations during some time frame window, and meanwhile the other databases could be accessed for read-only operations. Then you may have another time frame window where the second database would be accessed for read-write operations, whereas the first database is accessible for read-only operations. In all cases, you have to design a mechanism to handle the conflicts and monitor them in your configuration. In Oracle Golden Gate, the options that are available to detect and resolve conflicts are called Conflict Detection Resolution, or CDR. In this lecture, you will learn how to use the CDR options. This list shows the logic that the Golden Gate follows to detect the conflicts. For inserting a record that's already there in the target database, the unique constraints will simply disallow it, and that's how Golden Gate detects it. No data found is used to detect updating or deleting a record that doesn't exist in the target database. To detect the conflict of updating a record that's already there. To detect the conflict of updating a record that's already there but is different from the record image before the update operation, Golden Gate needs to have the image of the record before the update operation in the trail file. The same applies for the conflict for trying to delete a record from a target database which is different from the record that was deleted in the source database. Golden Gates need to have an image of the record that was there in the source database so that it can compare it to the record in the target database. This slide is showing an example of the workflow of an update statement starting from the source database all the way up to applying it in the target database in normal cases, when there isn't any update conflict. Consider the record as shown in the slide in the source database. Some update statement has been executed in the source database to update the grade value in the record from 4 to 5. At minimum, Golden Gate registers in the trail data the primary key values to identify the record and the value of the updated column. For CDR to work, you need to configure the database to include in its transaction log files the image of the record that was there before the apply operation. You can include the data of all the columns, or you can select some columns to be included in the logging data. This record image is called the before image record. In the CDR perspective, the record to be updated in the target database is called the current record. Suppose the current record is identical to the record that was there in the source database. Golden Gate will compare the before image with the current record. If the values of all the columns included in the before image equal to their values in the current record, then Golden Gate will proceed with executing the update statement in the target database. Suppose the current record was different from the before image record. In this example, the location column in the before image column equals to UK, but it is US in the current record. Golden Gate will compare the column values, and it will observe that the values of the location column are different between the before image record and the current record. Golden Gate considers this operation as a conflict, and you can configure Golden Gate on how to respond in such cases. This is actually what you configure in CDR. You, as a Golden Gate administrator, can define which columns to be used for conflict detection. You can also configure the response to such conflicts. You can either retain the before values, overwrite the current record with the updated values, check on the value of another column, such as timestamp, to decide which value to update, or you can reject the record and save it in the discard file. You will learn all about this in this lecture. To configure the CDR, you typically implement 3 steps. First, you make the required column values available in the database transaction logging file. You do so by enabling the supplemental logging option on the required columns, as you learned earlier in the course. Then you configure the parameter files of all the processes to handle the conflicts. Typically, you define which columns to be used for detecting the conflicts and how to respond to conflicts when they happen. Finally, it is recommended to write code in the parameter files to handle the errors that could happen but not handled by the CDR. You will learn about this point in a separate lecture. I have explained about enabling the supplemental logging before in preparing the environment lecture, and I will discuss it again over here. In order to have the before image saved in the supplemental logging information, you can use the command add tran data followed by the table name and the columns to be included in the supplemental logging data. The first example in the slide will instruct the database to save the primary key values, foreign key values, and the updated columns of the orders table. It doesn't include any other columns. Obviously, this is usually useless for CDR purposes. The second example will include all the columns in the supplemental logging data. This is fair enough for CDR purposes, but sometimes you don't need to use all the columns in a table to detect conflicts, because it does make the trail files take up more disk space. The third example includes, beside the primary key and the foreign key values, the columns quantity and description. You typically do that when you want to use those columns to detect the conflicts. The other columns cannot be used for detecting conflicts because their values wouldn't be there in the supplemental logging data.